Hello everyone, meet me again in the conic section in the topic of ellipse. So in the end of this lesson, you may define any vertical or horizontal ellipse, defining their equations and also their elements. So let's see and start with the definition of ellipse. What is ellipse? Ellipse is a regular oval shape traced by a point moving in a plane so that the sum of its distances from two other points called the foci is constant. So let's see if I have a point T1 here. So the sum of its distance to the first focus and to the second focus will be constant, and it is the same with, for example, I have the other point T2. So T2 F1 plus T2 F2 equal to the distance T1 F1 plus T1 F2. So that's the definition of ellipse. So let's see and derive the equation of ellipse starting from finding that distances. So here I have Tf1 plus Tf2 is equal to P1F1 plus P1F2. What is P1? P1 is another point on ellipse which is parallel with the foci. So here P1F1 plus P1F2 is the distance. So if I move P1 here, this is P1F1 and this is P1F2. If I move P1F1 to the P2F2, their distance will be the same since the ellipse is symmetrical. So P1F1 is equal to P2F2. So now I will have the distance of the point P1 to F2 added with F2 to P2. So that distance will be equal to A. Minus A to 0 and then 0 to 2A. The total distance will be 2A. Then here I prove that the length of any points to the foci will always be equal to 2A. So later we'll be not deriving all of the equation, but in short, from Tf1 plus Tf2 equals 2A, we will get this equation. You can see the derivation completely at the book if you want. And at the end, you will have this equation. You have a squared minus c squared times x squared plus a squared y squared equals a squared times a squared minus c squared. So for this a squared minus c squared, I will add the b squared. I suppose a squared minus c squared is b squared. Then I will have, substituting this with b squared x squared plus a squared y squared equals a squared b squared again. Then I can divide all terms by a squared b squared and have x squared over a squared plus y squared over b squared is 1. So that is the equation of the ellipse. And this kind of ellipse is a horizontal ellipse, as you can see it here. Then let's continue. For this equation of horizontal ellipse, we can substitute the value of y when this is 0. Then when y equals 0, make this 0, you have x will be plus and minus a. When x equals 0, you substitute this equals 0, so you have y squared is b squared or y equal plus and minus b. So let's see what point is that. The first point will be called the major vertex. You have minus a, 0 and a, 0. And then the second 2 points will be called the minor vertex. You have 0, minus b and 0, b. Next, what is the relation between A, B, and C? You can choose the point 0, b here and make the distance, which is 2A, lies here. So since this is an isosceles triangle, and the point on the ellipse will be equidistant to the two of the foci, and the length is 2a, then since it is isosceles, this will be a and this is also a. So here you can see the right angle triangle, and deriving the relation of a, c, and b, which is a square equal b square plus c square. And what is the directric lines? The directric line is defined by the ratio of a square with c. And since it is parallel with the y-axis, it will be x equals. You have two of directric lines at the left side of the ellipse and at the right side of the ellipse. Same with the lattice rectum. Lattice rectum is the line which passes through the focus. So you have also two lattice rectum line, one at the left with the equation of x equals minus c, and the other one is at the right, which equation is x equals c. The next one is the major axis. Major axis is the axis which contain the major vertex and two of the foci, while the minor axis contain two the vertex of the minor vertex. Next, we will define the length of the lattice rectum. Here I will substitute x equals c to the equation. So when x equals c, I will have c squared over a squared plus y squared over b squared equals 1. And then you can multiply both sides by a squared b squared. So you have b squared c squared plus a squared y squared equals a squared b squared. Now, since we need the value of y, for the lattice rectum line, substituting x with c, I will have the position of y. Then later I can find out the length here. Then find out y value will be like this. Finding it from a square y square equal b square in bracket a square minus c square, and divide, later you can divide it by a square, but you have to substitute a square minus c square. From here you got a square minus c square is b square. Then y will be b square over a. Yeah, here y square is b square, b to the power of 4 over a square, and you can take the square root, so y will be b square over a. Since you have 2 times of the coordinate of y for the lattice rectum length, so that the lattice rectum length will be 2b square over a. So after finding out our elements at the horizontal ellipse, now we'll see what about vertical ellipse. The first difference is here. At the vertical ellipse, you can see that the value of a square will be below the element of y square. How to pick a? A is the greatest value compared to b and c. And when the greatest value is below the y square, you can define this as a vertical ellipse. Then for the vertical ellipse, you can see it here. The foci, two of the foci and also the major vertex will be lies on the y-axis, or the y-axis later will be the major axis. For the for the minor vertex, it will be lies on the x-axis. The directrix line will be parallel with the x-axis, so that the equation will be y equals. For the ratio, it is not changing. The same for lattice rectum length. Since it is parallel with the x-axis, it will be y equals, and the value is not changing, minus c and c. So since the y-axis containing the foci and the major vertex, the y-axis will be later called the major axis, and the x-axis will be called the minor axis. So that's the difference between the horizontal and the vertical ellipse. Later on, you also have to modify all of the equation using the center translation from 0, 0 to alpha, beta. So what is different there? You can just translate all points. Alpha is changing the x value, and beta later will changing the y value, so that all of the equation will be shown later in the table. Before that, we see the things to define horizontal or vertical ellipse, the summary of what I said earlier. First, you have to pick the value of a square, which is the bigger value compared to b or c. And then, if a square below x, it will be a horizontal ellipse. The major axis will be on the x-axis, or it is a horizontal ellipse. Then, the foci, major vertex, will be also on the x-axis. The directrix line will be parallel with y-axis. If a square below y square, then the major axis will on the y-axis. Hence, it is a vertical ellipse. Then, vice versa, the foci, major vertex will be also on the y-axis, while the directrix line will be parallel with the x-axis. So here, x and y, always the opposite for the directrix line. The value of c usually determined using c square equal a square minus b square. Remember that a is the bigger value, so you have to subtract it from a square to get the value of c square. Foci and vertex will be translated along with the changes of the center m, alpha, beta. Alpha will be added to the x value, beta will be added to the y value. So after having all of that explanation later, you don't need again to memorize all of these equations. You can just adjust what you need based on the knowledge about the position of the ellipse. Is it horizontal ellipse? Is it vertical ellipse? Is it having a center on 0, 0 or alpha, beta? You can adjust the formula by yourself, no need to memorize all. Now, in this section, we will define which is equation of ellipse, circle, or parabola. For the first one, x squared plus y squared plus 3x plus 2y equals 5. You can see here that the coefficient at the x squared is 1, and also the coefficient of y squared is also 1. So this kind of equation will be not an ellipse, since later you will not having a different value of a and b. So this is actually an equation of circle. What about this one? You can see that for the degree 2 will be only at the x-axis, while you have 0, the coefficient of 0 for the y square. Then, this kind of equation will be a parabola. What kind of parabola? Yes, this is a vertical parabola. So usually I memorize it from the first grade high school. You have y equal ax squared, and you have the parabola, which is open up or open down. And then for this one, you have 0x squared, so only y squared is only at the y elements. So this is also parabola, and it is a horizontal parabola. What about this one? Is it an ellipse? So later, we will prove that this is an ellipse. You will define the value of a, the value of b, by completing the square first. But you can see, as you have a coefficient of x squared different from the coefficient of y squared, this is equation of ellipse. Sorry. And if it is in the form of complete square, you have 1 here and 1 there. This is not an ellipse, but what is this? Yes, this is a circle. And if you have different value of the coefficient, so it will be an ellipse. Okay, so after having information about is it ellipse equation or not, later we will solve some problems taken from your book. Let's continue. So this exercise is taken from exercise 3, number 1F. Define the vertex, the foci, the length of the major axis, the length of the minor axis, the eccentricity, the directrix line equation, lattice rectum line equation, lattice rectum length from an equation of ellipse 25x squared plus 16y squared minus 50x plus 64y equals 311. So we will make it become a complete square first by arranging the 25 of x and the 50x, and then the 16y squared and the 64y together. Next, we'll take out the 25, so you have 2x here, and then take out the 16, so you have 4y here. Next, make it become a complete square by having the half of the b and put the square, so this is a complete form. And then when you square it, you have x squared minus 2x plus 1. Since you don't have the 1, then you have to subtract to adjust. Same here, you have y plus half of b, and then you have square, and then you have to adjust by the 2 square outside, and this is equals 311. After that, you will multiply it inside 25 with minus 1, minus 25 plus 16 y plus 2 square minus 64 equals 311. Then I have 25 x minus 1 square plus 16 y plus 2 square equals 25 and 64 is 89. 89 become plus and added to 311 become 400, and then it will be divided by all divided by 400. So you have x minus 1 square over, so 25 divided by 400 is 16, while y plus 2 square, 16 divided by 400 is 25. So you have to check that at the equation of ellipse, 25 times 16, the coefficient of x squared and y squared should be equals to the coefficient at the right, so that it will be always 1. What next? The next one is defining whether this is a horizontal or vertical ellipse. So I stated earlier that the value of a will be the bigger one. So here you have to make the 25 as a square. We pick a first and then conclude that this is, since it is below the y element, so this is a vertical ellipse. So since I know that this is a vertical ellipse, later you can see it here. Please remind first for the vertical ellipse, which center is at 0, 0, while all of the foci and major vertex lies on the y-axis. So it will be 0C, 0A, so that later you can just insert the alpha, beta. So let's go. Compare this to the x minus alpha, then you have alpha is 1. Compare this to the y minus beta, you have beta equals -2. Here, this is your a square. So a is plus minus 5, and b is from 16 plus and minus 4. So what is the value of c? C is a square minus b square. So you have 25 and 16, so c is plus and minus 3. So that your value of alpha, beta, a, b, and c. So, so now please remember that this center is alpha comma beta. So we have to adjust the first of the vertex for the major vertex. Major vertex is added this with alpha. You have alpha comma a plus beta and alpha comma minus a plus beta, so that the value is 1 comma 5 minus 2, it's 3, and 1 comma minus 5 minus 2, it's minus 7. This is for the major vertex. What about the foci? For the foci, so it will be the same here, but changing it with c. You have c plus beta, and you have minus c plus beta. So it is 1 comma, c is 3, 3 minus 2 is 1, and this will be always the same. Minus c minus 3 minus 2, it's minus 5. The length of the major axis will be 2a. Length of the major axis, it is equals to a, so the length will be 10. For the minor axis, it will be 2b, so 2b equals 8. What about the directrix line equation? The directrix line equation here will be y equal plus and minus a square over c. A square is 25, c is 3, so it is 25 over 3 here, and plus 25 over 3 there. That's the directrix lines equation. Lattice rectum line equation will be, oh sorry, this is also added with the beta, which is minus 2. So the directrix line will be 25 minus 6, 16, 19 over 3, and also minus 2 here, so it is minus 31 over 3, the y equals. For the lattice rectum equation, added with alpha and added with beta, it will be c plus beta. So for this one, it will be 3 minus 2, so it is y equals 1. And then for the other one, minus c plus beta, so it is minus 3 minus 2, or y equals minus 5. Lattice rectum length. For the lattice rectum length, you have to remember the formula, which is 2b square over A. So it is 2 times 4 over 5. That's all. So we finished with the number 1F. This is taken from exercise 3, number 2J. Define the equation of the ellipse if given that the first for the center alpha comma beta is -1, 2. Eccentricity E, the formula of eccentricity is the ratio of C and A, that's 3 over 5. And then the lattice rectum length, which is 2b squared over A, is 64 over 5. For the major axis parallel with Y, so you can see that this is a vertical ellipse. Yeah, since the major axis is the bigger one, it will be parallel with the y-axis, or this is a vertical ellipse. Okay, so let's find out A, B, and C from these two equations. So I will substitute by C and A, so I will move away the value of 2b squared, so and changing it with 2 times b squared is a squared, the bigger one, minus c squared. So I have a squared minus c squared from here over A is 64 over 5. Next, I need to substitute C. C is 3 over 5A. So I have A squared minus 3 over 5A squared is multiply A to the left, to the right. I have 64 over 5A. Then let's simplify. 2A squared minus 9 over 25A squared is 64 over 5A. Then you have 2A squared minus 18 over 25 or this is 50 over 25. 50 over 25 minus 18. Since we don't want the value of A become 0, so we can cross one of the A there, because no A equals 0. So you can have 50 minus 18 is 32. A multiply 25 and 5, so you have I think I make a mistake. Wait. Yeah, I found it. So here I'm not multiplying with the 64 yet. Then I have 32A multiply 64 and then 25 over 5. You have 32A equals 320, so A equals 10. So that C, which is 3 over 5A, will be 6, and B, which is square root of 10 square minus 6 square, you will have 8 plus and minus 8. Then our equation will be x minus alpha square Alpha is minus 1, so you have x plus 1 square, and y minus beta square, beta is 2, minus 2 square. Then adding the a square, since this is a vertical ellipse, so a square is here, and then b square is there, 8b square equals 1. So this is our equation of horizontal ellipse. So you may continue your exercise from the book and let me know if any question in the comments. Okay, good luck for your learning and stay healthy all. Bye-bye.